Hello everyone. So we have an excellent question from the chapter of center of mass. This question will help you revise a lot of concepts from this chapter. Not just revise, I'm very hopeful that it will also help you learn many topics from this particular chapter. Okay. So what we have been asked to find is that we have to find the area of the curve, this curve, which is basically the intersection of the areas or the intersection of the curves y equal to x square and x equal to y square. So let me just draw this first. Okay. So as you can see, my drawing is terrible. This should look like a square, but it's looking like a rectangle. But anyways, we have to find the area of this. Okay. Now, with the methods which we learned in class 11 and class 12, it's not possible for us to find this. Okay. I think there's one particular method which we will learn in mechanical engineering, but I am not a mechanical engineering student. Okay. Our But still we have to find the center of mass because that is what the question asks, right? So let's do one thing. Let's find the area of this intersection. The area will be very simple. It will be root x minus x square dx from 0 to 1, right? And the answer to this integration will be 1 by 3. Very interestingly, if you see this part, this slab, I would say, not slab, let's call this part A. Okay, I have to name this many times. This is A, this part is A, this part is B, and this part is C. Okay, so part A and part B, both of them will have same area, right? For very obvious reasons. I mean, you can think about this as well, why they will have the same area. You can calculate it for yourselves as well. It's not very difficult. Anyways, they will also have the same area, that is 1 by 3. Okay, now uh, you will see that it's easier to find the area of block A and block B. Okay, what we will do is that then we will use the negative mass method to find the center of mass. Okay, that is, we will find the center of mass of A and center of mass of B and the center of mass of the square, which we already know, and then we will eliminate parts A and B and we will get the center of mass of C. Okay, that is how I am planning to do this. But first, the challenge is to find the area of A and B. Okay, I mean, if we find A, we will get B also. Okay, because it's symmetric. So let's find the center of mass of part A. Okay, so for these kinds of bodies, this is the formula. Okay, integration x dA divided by integration dA. Okay, so we can replace the x with x dy, right? Why do we do this? Let me explain it to you. In order to find the center of mass in x, what we can do is that, right? Okay, this is for y actually. So let me show y first, then I will show x. Okay, this thickness right here is dx, and this length here is y. Okay, in order to find the center of mass of this block, the y center of mass for this block, what we will do is we can take this small strip over here at a distance x. Okay, where x will tend from 0 to 1, and we will find the y center of mass for each of these strips. Okay, and then when we integrate, we will automatically get the y center of mass for the entire part A. Okay, now when we try to find the x center of mass, what we can do is we can divide it this way, right? We can divide it vertically. Okay, this way we can find the x center of mass for each and every small strip, and when we integrate it all together, we will get the x center of mass for this step, for this strip, for this entire body. I'm sorry. I hope you have understood. Okay. So yeah, let's now continue with our calculation. This will be integration x dy. Now you can see that the variable is in y, right? We need to convert it to x, or I'm sorry, we need to convert this x square and x into y. Okay. So we know that x square is equal to y, right? From the equation that is given. So we will just write y dy divided by root y dy. Apologies. Okay. And we will integrate this from 0 to 1. And you will get the answer, which is equal to 3 by 8. Okay. Now let's find the y center of mass. The y center of mass, again, we will find it very similarly. It will be y dA divided by integration dA, right? Now when we place the value of dA over here, it will be y dx divided by integration y dx. And y square, we can write it as x to the power 4 because y is equal to x square, right? So this will become x to the power 4 dx divided by x square dx. You will integrate this again from 0 to 1, and you will get your answer as 3 by 10. Okay. I hope you have understood this. Now, if you apply common sense, or if you just visualize this diagram, you will realize that block B, you don't even need to integrate in order to find the center of mass of block B. You don't even need to integrate. Okay, so for B, the center of mass of X will be 1 minus 3 by 8, which is equal to 5 by 8. You know why? Because, say, if I have got my center of mass, the X center of mass for block A over here, the center of mass, X center of mass for block B will be somewhere here, right? Since it's the exact opposite, the sum of these, the X coordinates of these 2 points has to be equal to 1. Okay. And the same goes for Y center of mass as well. This will be equal to 7 by 10. So now that we have the center of mass values for blocks B and A, it should not be very difficult to find the center of mass of C. We will be using the mass removal technique, wherein we will consider the entire square, that 1 into 1 square, and then we will remove blocks A and the block B. Okay, the blocks A and B we will remove. Okay, so the X center of mass, which has been asked from us, the final answer, that is, we can write this as integration mixi divided by integration mi. Okay, this is no longer that continuous mass distribution uh, which we had to use in order to find the center of mass of blocks A and B. Okay, we can now consider the entire block to be concentrated at a single point. Okay, that is why we have made the concept of center of mass in order to make our lives easier, right? So let me now just put all the values. Yeah, so it will be, this is equal to half sigma into 1 square is the mass. Okay, sigma is the surface mass density, and half is the coordinate. Okay, the center of mass coordinate of that square. Now we will eliminate blocks A and B. So this will be sigma 1 by 3. The area we have already found out, right? This will be 3 by 8 sigma 1 by 3. And the summation of mi will be sigma 1 square minus sigma by 3 minus sigma by 3. So the answer for this won't be very difficult to calculate. This will be sigma by 2 by sigma minus 3 divided by sigma minus 2 sigma by 3, right? So this will be sigma by 6 divided by sigma by 3, which is equal to half. This is the x center of mass which has been asked from us. Okay, and the y center of mass will also be half. Okay, I'm not calculating this. The calculation you can do it on your own. So that is the y center of mass, half comma half. Okay, and therefore the distance, the question which has been asked is the distance of the center of mass from the origin. The answer is option C. I'm sorry, let me just calculate it once. This will be root 1 by 4 plus 1 by 4, right? Which is root 1 half, which is 1 by root 2. Okay, yeah. So option C is the correct answer. Thank you.